Hi, this is Brother Barnes, and we're going to crunch some Graham's Law data from an experiment. We put concentrated hydrochloric acid in one end of a tube on some cotton and then ammonia on the other end, and we tracked to see how fast each one of them moved. And this is an average, by the way. Basically, Graham's law says that the mass of a molecule is inversely related to how fast it moves. And so the challenge is to determine the experimental value of the molar mass of hydrochloric acid. We know it to be 36.5 grams per mole. We're going to try to see experimentally what we get. To get rid of this radical, I just squared both sides, and then I solved for the molar mass of the hydrochloric acid here. So let's take the rate of ammonia movement, 0.179, and let's square that. And we know that the molar mass of ammonia is 17 grams per mole, so we're going to write that there. And the rate of the hydrochloric acid movement was 0.123, and we're going to square that. And so let's put this in our calculator and see what we get. 0.179 squared, enter, multiplied by 17, enter, divided by 0.123 squared, enter, is exactly 36, and that is grams per mole. That is the molar mass. We know that the accepted value for hydrochloric acid is 36.5 grams per mole. So let's plug this experimental value in here, 36, and see what we get for experimental error. 36.5 minus 36, enter, divided by 36.5, and I got 0.0137% error. Is that true? That seems too good to be true, doesn't it? 36.5 minus 36 divided by 36.5, enter, times 100. There we go. Got to get the 100 in there, didn't we, mates? All right, let's try it again. We got 1.37% error. Not bad. Not bad, mates.